Our next speaker is a data solution architect focused on machine learning and blockchain. Please welcome to the stage Microsoft's Haseeb.
Thanks so much, guys. Hello. All right. Hi, guys. My name is Haseeb. I work for Microsoft, and I'm covering the EMEA region. So I'm in fact, an ex-IBMer, so joined Microsoft very recently. So yeah, I think it's sort of a good way of continue the Hyperledger Fabric conversation, which Dr. Krishnan was doing. So the idea of my talk is that I will discuss the enterprise aspects, our learnings, different mistakes which people do when they try to implement a blockchain-based solution, especially for enterprises. So I will not talk about ICOs, I will not talk about public networks, I will not talk about cryptocurrency, I will talk about those enterprise-grade applications. So where we see lots of value, lots of traction within industry. So first of all, let's see. So we all like hear this thing, we all like talk to different people, and there is a huge misconception around technology. So people consider Bitcoin, Ethereum as a blockchain technology, but this is the first thing we talk to different people about, that they have to consider blockchain protocol, they have to consider blockchain technology, they have to consider this limitations, and so on, rather than confusing it with, for example, Bitcoin. So in summary, first of all, the key learnings that we have done in past couple of years, so I mean, again, like my experience goes from IBM, now at Microsoft, so talking to or like working with a number of different customers, ranging from startups to healthcare organizations to organizations like NATO and European Commission to different financial sector institutions. So the key learnings are that the benefits of blockchain are also its biggest pitfalls. So for example, we always position blockchain for its simplicity and efficiency. We say that it can simplify, it can automate, it can improve business processes, but this is where lots of complications come in as well, because there is no clear understanding around limitations of blockchain technology. So I mean, if you are thinking that blockchain is going to solve all your problems, this is a big mistake. Blockchain is one of the possible technologies. It's not the only technology. I mean, blockchain will serve as a source of truth. You can have a shared data repository which you all can trust, but it's not a place where you want to have all your compute to locate. It's not a place where you want to have advanced analysis, machine learning, SQL-like queries, etc. So I think it is one of the possible technologies, it's not the only technology. Then we always position, we say that blockchain is going to provide a trusted, secure, transparent data repository. Now again, this is also our biggest pitfall, because when we talk about data repository, we have to be extremely careful what we put on this data repository, what we want to share with different members of a consortium, how we want to manipulate that data, because one mistake, if you don't know your actors, if you don't know who is transacting with the blockchain network, who is replicating your ledger, it can be a big problem. Digital identity. Everyone talks about blockchain. One of the cornerstones of having a successful blockchain implementation requires a strong aspect of digital identity. I think there were like a couple of talks today around this topic as well. Then the value of blockchain is all around decentralization, collaboration, and then the aspects of regulations, aspects of how different compliance aspects will be taken care of, they're always forgotten. As I said earlier, the blockchain will not replace the compute part. And then there's always reservations, there are always concerns around external data, external compute, and how we can solve those different things. So again, I mean, from my experience, we start a blockchain project, we do a proof of concept, everything is good, fine, but as soon as we want to go to a production-based or a production-grade solution, we have to go through all these reservations. So I mean, not only are these the key aspects, the key learning that we have done over the course of a couple of years, but these are also the pitfalls. Now, in terms of best practices, what we make people understand, what we make people think along these following 5 different lines. First of all, look into governance. And the governance can mean that as simple as the aspects of network administration. Who will do that? Do we trust that authority? Are we going to talk about a decentralized network administration? Again, the issues around key management, the issues around external compute, all those issues are still there. Again, we're talking about a consortium network, a business network comprising different organizations. Who will have the authority to vote? Who will add some new member to a consortium? What if we want to take away the rights of a given member from a consortium? How will we bring that transparency? How will we formalize all those requirements, all those different criteria? In fact, in terms of a consortium building, one of the biggest hurdle is to talk about different governance. So imagine 2 different banks sitting on the same table and they are arguing around the network infrastructure. Environmental restrictions. We want to impose that our blockchain network needs to have a certain version of a blockchain protocol. This is how it should behave. This is how it should report back to us if something bad happens. Again, the aspects of governance. Change management. Smart contracts will never stay the same. They will evolve. How will we manage the change aspect? How will we create a CI/CD environment around our code base, around our smart contracts? Then about confidentiality. The things as simple as favoring transparency over confidentiality. A very misunderstood topic. The beauty of blockchain is to have a very transparent system, a very transparent environment, but you always have to consider the aspects of confidentiality aspect. IP stored on ledgers. How many times I have talked to customers and they are concerned by exposing their intellectual property and business concerns, business-sensitive logic on the blockchain network. Again, something that we have to address. So, the responsibility of developers, responsibility of architects is to look into all those different aspects, be it governance, be it if it's around scalability, if it's around compliance, if it's around ecosystem. We have to think about all those different aspects if we want to have any success within enterprise blockchain adoption. Now, the industry, the way we see the industry evolving, we started with this Bitcoin, then came the notion of smart contracts, and now where we see all the development happening is all around blockchain 3.0. It means that making blockchain cloud serviceable, providing our confidential compute environments for blockchain, creating an identity solution which can work with enterprise-grade applications, creating a secure way of interacting with the blockchain network from outside world. What if you have different ledgers for your different cases? How will you provide integration between different ledgers that way? How will we support our data repository for our analysis, which is backed up by blockchain? So all those aspects are the ones we are seeing lots of development happening towards. Now, we took that learning in our team, and we said, okay, let's think about all those factors which is causing enterprises to not adopt blockchain so easily. We said, okay, how we can reduce that barrier to entry. And this is essentially Microsoft's approach. So we are not talking about concrete solutions. We're talking about generic frameworks, generic tools, empowering developers so that they can develop enterprise-grade applications so that they can satisfy all those functional and non-functional requirements for enterprises. So first of all, what we do, we provide or we follow an open cloud approach. It means that we take the open source blockchain ledgers. I think right now we have 6 ledgers supported. So, ranging from Hyperledger Fabric 1.1 along with Composer to Ethereum, to Quorum, to multi-chain chain, to Corda, etc. And we believe that in an enterprise, you will be using different blockchain ledgers for different purposes. So it doesn't make much sense to limit an organization or limit you to only do the development based on a single ledger. Then on top of that, the aspect of openness means we need to support a hybrid approach. Now, if you think about this, blockchain has its beauty in decentralization, and would it make any sense to limit blockchain networks to reside within a single cloud vendor? No, it does not. So what we're doing here is that we are developing templates using which you can have a complete hybrid network along with the best practices, security concerns taken care of. You can have a part of your network in Amazon, part of your network in Azure. You can have part of your network in IBM software. You can even have a part of your network on-premise as well, using your own data center. So I mean, in essence, the network deployment has become easy. You have a bunch of different options over here, and there's like nothing stopping you to only use a single cloud vendor. Then, a couple of years back, we started working with Intel. So Intel came up with software guard extensions, and we said, okay, what if we can take this aspect of confidential compute and build up a framework which can be usable by blockchain networks as well. So we started up this confidential consortium framework project. It's an open source project. The technical paper is available on GitHub, and the code will be published sometime after summer as well. So what we tried to accomplish in this framework, we said, let's talk about the governance first of all, because that's the biggest concern. So in terms of governance, we wanted to formalize who can join, who can leave, the policies we want to enforce, the environmental constraints we want to put on top of our blockchain network, and so on. So we said, okay, let's have that network administrivia, and let's surface that network administrivia very, very transparently as a blockchain ledger as well. So essentially, it means that Confidential Consortium Framework will create a sidechain for all your network processes. Aside from governance, you can have a very fine-grained confidentiality model implemented on top of your ledger as well. So now, Hyperledger Fabric is one example which has a good framework around managing confidential or private transactions. But when we talk about, for example, Ethereum, I mean, Ethereum has a very different model. And so we said, okay, we want to allow developers to have or to work with different ledgers. So let's provide one confidentiality model which is applicable to all ledgers, whether they support it or not. So we said, okay, let's provide a very fine-grained confidentiality model in which not only I can specify that I need to share my transaction to an organization, but I can also specify that these given roles can access, for example, pricing details of my transaction, and some other roles might want to access, for example, our contractual details. So I mean, those fine-grained confidentiality controls are in place as well. And the third thing is the performance. So since we started working with Intel on this trusted execution environment, we tried to relax the limitations of the blockchain execution in terms of how they are deployed and how they are executed by allowing different pluggable consensus models. And we have done some benchmarks in which we achieved close to 2,000 transactions per second. On a normal Ethereum, which, let's say, I mean, Ethereum proof of work, which is around like 10 to 20 transactions per second. And similarly, I mean, if we compare it with, for example, parity-based networks or, for example, click-based network, again, the performance is way better. So governance, confidentiality, and the performance. Then let me think about the blockchain in terms of a full, complete ecosystem. So we think that you would want to have a key management solution. You would want to have an integration with IoT devices. You would like to have, let's say, a SQL store or some NoSQL store or some other data repository backed up by blockchain for all your, let's say, data analysis needs. You also want to have some sort of an identity management solution. You also want to have a mechanism in which you can secure your off-chain compute, have a very confidential compute environment around the off-chain compute as well. You also want to secure and attest any messages, any triggers which are coming out of your blockchain network as well. So we said, okay, let's take all those requirements, build all those different pieces, different services together, or if we have services available already, let's leverage those services and make them compatible with the blockchain networks. So this is where this development platform notion comes into play. So you can have your production-grade blockchain network through templates, in a very hybrid and a very open environment. If you want to plug in a confidential consortium framework, you can do that as well. And for a development perspective, to develop a full application, you have all those different services available. So among those services, there's a service called Enterprise Smart Contracts, or called Triplets as well. This is also an open source project. Its code is also pushed on GitHub as well. And the idea of this Enterprise Smart Contract is that we try to address the intellectual property aspect and change management aspect of the blockchain, of the blockchain-based applications. So it means that given the definitions of a traditional smart contract, which not only contains the state, but also the business logic and the ledger transactions for the underlying ledger, we abstract out those details into a byproduct, into a separate contract called Enterprise Smart Contracts, which has to run in a confidential compute environment, and the entire network has to agree upon the execution or the trust aspects they have towards that piece of code. And then lastly, the value of the blockchain is the fact that we have to, first of all, prove a business value. I mean, blockchain is a technology which is begging for a solution. So, I mean, countless number of times I talk to customers and they say that whichever problem they have, they can possibly solve it through a non-blockchain based technology. So this is a very difficult debate to win. So for that we built this Azure Blockchain Workbench, and the idea of the Blockchain Workbench is that it scaffolds all those different services together so that you as an application developer can focus on application development rather than thinking about how you can create, for example, identities, how you can create different roles, how you can integrate IoT devices to your blockchain-based network, how you can have a SQL store or, let's say, a data lake implementation backed up by blockchain, etc. And one of the beauty of Blockchain Workbench is that it is network agnostic. So it provides developers a REST API, which is at a higher level, and your application, which is built on top of your Blockchain Workbench, can work seamlessly with Hyperledger Fabric as it does with Ethereum. And then the entire operation and management aspect of the application is also taken care of. So, I mean, I've talked about those things already, so I'm going to skim through those very quickly. So you mentioned about Ledger as a service. You have different options available. So some of the key takeaways are that they are all open source. There's nothing proprietary over here, and they are all supporting hybrid strategies. I mentioned about the confidential consortium framework and open source framework. It's a consortium-based approach. So we are not talking about the public networks. We're talking about known identities, and this is based on the idea that a ledger can operate on a trusted execution environment, whether it's in hardware-based system like Intel SGX or through a software-based stack like Virtual Secure mode. And this is not really a ledger. It is just an enabling framework. So the core processing of the ledger remains the same. It provides a secure node-to-node communication. It provides the governance aspect, as I mentioned, as a separate ledger in which all the network administrivia is managed. But the core data model of the ledger, the core functionality of the ledger, let's say in case of Ethereum, EVM, all those aspects remain the same. Now, in terms of a transaction flow of the confidential consortium framework, so you have even more fine-grained controls. You can even have controls in which you can specify whether you want to favor throughput or latency by providing different levels of batching. You can have different consensus algorithms for different cases for your blockchain-based system. And you can, of course, you have the secure communication between different nodes. And again, the entire transaction flow is agnostic to your underlying blockchain ledger. Right, so the key takeaways in terms of a confidential consortium framework: A, it's open source, it's based on TEEs. We have benchmarks, which is based on Raft consensus algorithm, reaching around 2,000 transactions per second compared to 11 to 12 transactions per second on a normal Ethereum. Similar numbers are available for Hyperledger Fabric as well. So there is performance gain from a Hyperledger Fabric perspective as well. And Again, this is all based on a standard cryptography, and you would like to use this framework when you are dealing with a high throughput situation, when you are dealing with a situation where you want to have a very strong governance model in place and where you want to have a very flexible confidentiality in place. So it's more of a production level scenarios where you want to plug in this framework. Right, and as I mentioned about the enterprise middleware, different tools available, etc. So one of the most important aspect is the identity management. So imagine that we are talking about a business process, we are talking about different organizations having their own business users, etc. We cannot expect them to create keys, maintain their wallets themselves, and then keep them secure. In case of public networks, they have an incentive. In case of a business network, they don't have much of an incentive. So what we say here is that for that, you need to have a higher level or sort of an abstraction of the identity management solution, and then you have to tie that up to the underlying blockchain-based identities. Now, there's always a discussion around where those keys should be stored. Centralization has a benefit because, let's say, all the organizations sit together, they talk about the governance, they talk about that we are going to use an HSM for the keys. That's how we will secure the keys of all the participants of our business process. That works fine. But if there are any reservations around the centralization of keys, you can always have a decentralized solution over there as well. But keep in mind that in case of a decentralized solution, you won't have much control. And if, for example, an organization implements a key store in a bad manner and the keys are compromised, then your entire trust on the blockchain network will suffer. So again, this is just a recommendation over here. But in terms of services from Azure, you have the key management services, you have the identity management services, you have the data services, which can provide an off-chain data solution, which is backed up by blockchain, meaning that any transaction which gets committed to a blockchain network will get committed to your will get committed to your off-chain store as well. And those data services make sure that even those data services are tamper-proof. But it's not the same level of tamper-proofness as we have from the core blockchain network. But since those data stores are backed up by the blockchain network, you can safely do your analysis based on your data stores, data services, and then in case of any conflicts, you can simply revert back to your blockchain-based ledgers. So what we know about the smart contracts, we have state. Either there might be some dynamic inputs coming from external world. You might have some static part as well, and then you have a part of business logic. And this business logic, this state machine implementation produces ledgers for your underlying blockchain ledger. Now, this is this V1 package that we know of. So a smart contract contains the state machine implementation, properties, and those ledgers. And we take a view that the smart contracts should emit those ledger entries, those transactions. They should not deal with logic as much as we normally think they should. And the meaning and the reason why it is that whenever we talk about oracles, whenever we talk about external triggers, external event going to a blockchain network, there's always a concern whether we can trust that external service or not. Secondly, the way those smart contracts are deployed, they are deployed to this entire network, and the way this consensus algorithm works is that the incoming transactions are applied to the latest state of the ledger, and this entire network has to agree that the resulting state is consistent. So there's no separation of concern, and if for example, we have to do any code changes, any change management, we will have to redeploy that smart contract. Either we have to create proxies for smart contracts, we have to create some sort of a mechanism where we can be sure that the usage of smart contract is as it's intended. And I mean, and this execution and deployment has a big scalability concern as well. And I was mentioning about enterprise smart contracts or triplets. So what they do essentially is that they create a separation of concern between your off-chain compute. They encapsulate them in a trusted execution environment, and they have this binding process in which not only you as an organization can trust your own code, but also the entire network, which is comprised of different members, can trust that this piece of code, this trigger, is coming from a service. We all agreed in the beginning. We know that it's coming from the same trusted execution environment. We are sure that it's coming from the same container that was provisioned, is coming from the same host that we agreed upon in the beginning. So it is a way of creating a separation of concern, and that way you can also control your intellectual property, and you can easily provide version controlling, or you can very simply do a version control over there as well. So the way, the way Flow works, so it's like an onion-based approach. So you have different levels of authentication. So not only your smart contract, which you deploy to the blockchain network, will get binded to this off-chain compute part, this enterprise smart contract, but also the entire provisioning cycle in terms of provisioning of a secure enclave, provisioning of a container, provisioning of a host, everything is managed through keys. And the blockchain network, whenever it receives, let's say, a trigger, it knows that the trigger is coming from the same piece of code that we all agreed upon. It's coming from the same secure enclave, it's coming from the same container, and then so on and so forth. But I mean, the technical paper is available. The code is also pushed in GitHub. If you want, you can also have a look into kublets as well. Right, and then lastly, as I said, that we have a blockchain workbench, which makes the application development easier. It scaffolds all those different services which you might need in terms of an application development. It's flexible. I mean, if you, let's say you are not dealing with IoT-based solutions, IoT-based scenarios, you can skip the IoT part. But the application development is based on a higher-level API. It means that, I mean, for an application developer, it doesn't matter if your application is intended to run on Ethereum or on Hyperledger Fabric. So it means that from a blockchain perspective, you have different proxies in place. And those proxies make sure that whichever ledger you use, the appropriate APIs, underlying APIs are used. So the application development happens in a very generic way. From an application development perspective, you are dealing with a different level of identity management solution. The developers are not concerned by storing the keys or creating wallets themselves. All they have to do is to onboard, for example, a business user or let's say a consortium member. The keys will be handled through a key vault store. Again, as I said, I mean, this key vault store can be decentralized as well. It's again a matter of pros and cons around a consortium. And once you have that business process, that workflow, it's only a matter of making sure that this workflow works fine. And of course, I mean, you can deep dive into your blockchain ledger. You can see how it looks like, etc. But it makes the job of application developers super simple. Some of the aspects, I mean, some of the key aspects are that, I mean, it has this IoT integration. So, I mean, it takes care of IoT device registration. It assigns unique identities for IoT devices. It manages the keys for IoT, keys for those devices as well. It comes up with both iOS, Android, and a web app. So it's a matter of developers to customize that app based on your own liking. And then it has a bunch of different core components around proxies, around different DLT routers, so meaning that you can have a transaction and you can specify rules that this transaction has to go to a Hyperledger Fabric, and this transaction has to go to Corda, and then so on and so forth. And then by design, this entire transaction flow, once it's committed to the blockchain ledger, it's also committed to an off-chain store as well. So right now, I mean, the default one is that you have a SQL store in place, but I mean, you can change that SQL store to, let's say, a data lake, or for, let's say, a document store, you can change that store to, for example, Amazon S3, and so on and so forth. So again, the purpose is that it gives a reference architecture, a built-in solution for developers to start implementing their business processes, their business cases, rather than dealing with all the complex integration between different services. Right, so whenever we again, forget about all those different names. So whenever we talk about, let's say, an application, so we talk about different layers of an application. We talk about the UI part, we talk about the data ingestion part, we talk about the business logic aspect, we talk about the story aspect, reporting, and so on and so forth. And this is where, I mean, you see here, I mean, here we don't have any blockchain in this entire ecosystem. And this is where we see the blockchain. Blockchain is supposed to be used for a long-term archival solution. It is secure, it is transparent, it brings transparency. This is what this entire network can agree upon, but do not consider blockchain going towards a UI side or reporting side or covering your business logic layer. So treat blockchain for what it is meant for. So in fact, this is like one mistake I see people doing all the time. And again, going back to the fact that we as the developers, we as architects, we have to think about these aspects very carefully. We have to think about confidentiality. We have to talk about governance, easier or not. We have to look into those things. We have to look into compliance. We have to make sure that if we are onboarding someone, that person is authorized. If we are adding a new member node who will have a copy of the ledger, we have to make sure that he is authorized to do so. We have to think about the ecosystem, not only about the blockchain and this decentralized application. We need to have a lot of service around that as well. So just a recap. So from a developers and architects perspective, the approach for Microsoft is that we want to provide tools which can enable developers to develop enterprise-grade applications. It's not about public networks, it's all about consortium networks, it's all about creating enterprise-grade applications and then covering all those different bases, different issues that enterprises face in terms of blockchain-based adoption. You have different open source projects, so luckily the entire stack is more or less open source. So you can have a look at a confidential consortium framework, you can have a look at enterprise smart contracts, have a look into blockchain Workbench as well. You can modify the template, you can start playing with that. You have a much higher level of abstraction to do your application development. And even we are releasing a tool in which you can document your business workflow in an Excel document or in sort of a workflow, different rules, and the smart contracts will be produced automatically as well. So it's a matter of designing your workflow, not a matter of thinking about all the internals. And again, those internals are open source. They are available, and if you want to deep dive into those things, you should definitely do that. And finally, consortium building is extremely hard. This is in fact like one non-technical thing that we always face. So, and this is where we have to be open to talk about governance. We have to be open to talk about confidentiality. We have to be open to talk about the confidential compute where we can secure the data coming from external world and so on and so forth. So we have to be open about this thing. Always question the participation to a blockchain network. So make a distinction who is a member of a blockchain network and who is just a participant, whom we are permitting to transact and who will have a copy of the ledger. Always protect personal identifiable information. So in Europe, we have lots of concerns around GDPR, etc. So we try to address those from the get-go. We think very carefully what did I want to put in terms of blockchain. Protect your intellectual property. Once it's in public domain, once it's shared within a consortium network, you can't really control that one. Hybrid has a very strong value. Please leverage this. And hybrid means that supporting a blockchain network on different cloud vendors and on-premise as well. Think about ecosystem, think about the limitations of technology, know your actors, what they want to do, how they will interact, etc., and always qualify your business case. Thank you so much.